What do you mean by the state of equilibrium? What do you mean by equilibrium state? Yeah, come on. Numericals, I'll do it once when the class discussion is done. Okay, that is why I told you to bring that book too. Okay, today they said that they will distribute this booklet, red booklet, those who didn't get it. There is no if here, we will 100% solve the problems. For the exams, problem comes based on delta G is equal to delta H plus delta nRT, delta H minus T delta S, delta G is equal to delta U plus delta nRT. Okay, so many problem comes, we will solve it, right? Let me complete that portion of the, for the exam, the chemical kinetics, equilibrium, all chapters will be coming. So I will complete the portion and then I will make you to solve. This is the reason why I told you, please bring the booklet tomorrow. Now the problem for me is that only 4 of them have booklet in the class now. Okay, they have not given, they will give it today. Okay, only 4 have the books today in the class. If I discuss the question, from where will you look at the question and the whole class will go disturbed. And whom I will blame? Whom I will blame? This is my problem. Okay. So, yes. So, the equilibrium is plainly of 2 different types. Which are the 2 different types of equilibrium? Chemical equilibrium and physical equilibrium. What makes the difference between the physical equilibrium and chemical equilibrium? What makes the difference between a physical equilibrium and a chemical equilibrium? What do you mean by basically the concept equilibrium? What do you mean by the term? What is equal? Yeah, the rate of the forward reaction becomes equal to the rate of the backward reaction. What do you mean by rate of a reaction? What do you mean by rate of a reaction? The rate of formation of products is rate of forward reaction, and the reverse reaction is, however, with the speed by which. The rate means the speed. Okay, we measure the speed of a vehicle by measuring the distance travelled in unit time. Similarly, we measure the rate of a reaction by taking the concentration change in unit time. When I say concentration change, you have to imagine a reaction. At the start of a reaction, the reactant concentration is maximum and product concentration is 0. At the start of a reaction, the reactant concentration is maximum and product concentration is 0. Right? The reaction has not yet started. Now, after the start of the reaction, the reactant concentration decreases and product concentration increases. Now, if we plot the reactant concentration against time, if we plot the reactant concentration against time, what happens here is, we get a decrease as the reactant concentration decreases after each unit time, right? Now what happens to the product concentration? After the start of the reaction, the product concentration increases, right? Now when the reactant concentration is decreasing and when the product concentration is increasing, it comes to a steady balance state. somewhere after a time t, by which the rate of the forward reactions becomes exactly equal to the rate of the backward reaction. So this is the time we call the reaction has attained equilibrium. Equilibrium. Now we are taking a state change. Physical equilibrium is the phase transition or the state changes. Now from solid to liquid or liquid to gas or solid to gas, the phase transition takes place. Okay, so we take an example of water boiled in a beaker. We take the example of water boiled in a beaker. Right, when the water is boiled in a closed container. The first condition of the equilibrium is that the vessel must be closed. Otherwise, as we discussed earlier in thermodynamics, matter escapes. Right? And so, without leaving the matter out, we have to close. What happens is, after reaching its boiling point, matter will start evaporating. So, the water vapor will start filling here right above the liquid level, liquid surface. Now, as the vapor's concentration increases, it will reach a state known as saturation. What do you mean by the saturation? It reaches a state known as saturation. What do you mean by the saturation? Yeah, when there is a space above the liquid level. Now the liquid level is there is a gap between the closed vessel and the liquid layer. And when the whole space is filled with the water vapor, we call the thing as saturated. It has reached saturation. Now the thing is, there are all the gaps above are filled. There are no more gap for the gas to rise up. Complete it is filled. It reached the point of saturation. Now still if we heat, what happens? When the gases rise up, the same amount of, say like if 10 molecules of water as water vapor rise up, in the same time, simultaneously 10 molecules of this gases will come down. Okay, will come down, condensed down back to the, will drip back to the liquid. Understood? So here we say that the rate of evaporation is equal to the rate of condensation. This is what we call as the rate of forward reaction and the rate of backward reaction. When these two are equal, we call it as at equilibrium. Right? So, the physical equilibrium, there are three different types of physical equilibrium as the phase transition takes place. It is solid liquid equilibrium, the solid liquid equilibrium. Okay, what will be the forward reaction for the solid liquid equilibrium? What will be the forward reaction for the solid liquid equilibrium? There is no gas involved here as it is solid to liquid. Okay, solid to liquid it is. So, at the solid melting or fusion is the forward reaction here. What is the backward reaction now? Condensation. Wonderful, condensation. Now, the rate of fusion, when it is equal to the rate of condensation, the solid liquid equilibrium is attained. Now, if I go to the liquid gas equilibrium, yeah, vaporization, rate of vaporization or rate of evaporation when it is equal to the rate of condensation again. It's known as at equilibrium. That is what we have discussed now. This is the liquid gas equilibrium. Right? Now what is solid gas equilibrium? Sublimation. Wonderful. Solid gas equilibrium, all substances cannot undergo solid gas equilibrium. The substances which directly convert from solid state to gaseous state or back from gas to solid will undergo this particular equilibrium. And such substances, examples of such substances are naphthalene, camphor, ammonium chloride, etc. Okay, so only those substances will undergo liquid gas equilibrium, right? Solid gas equilibrium, right? Solid gas equilibrium. So this is sublimation. Sublimation is defined as the conversion of solid to gas or from gas to solid, right? So that is all the physical equilibrium. It is only the phase transition. Now coming back to the chemical equilibrium. What is happening here is a chemical reaction. Yeah. That generally if we speak about physical equilibrium, it is reversible. Okay, easily it is attained back. The chemical reactions which are reversible are taken under chemical equilibrium. Okay, the chemical reactions which are reversible is taken under chemical equilibrium. Now, if we take a chemical reaction, there are certain laws applicable for the equilibrium, and the first one is law of mass action. What do you mean by law of mass action? Law of mass action in equilibrium is regarding rate of a reaction. Okay, the rate of a reaction is directly proportional to the concentration of reactants. Okay, the rate of a reaction is directly proportional to the concentration of each reactant raised to its stoichiometric coefficient is the law of mass action. So, if we write the law of mass action for this particular reaction, it is R directly proportional to N2, concentration of N2. With a square bracket, we denote concentration of. How do we read as concentration of? So, concentration of N2 into concentration of H2. Now, its stoichiometric coefficient must be raised as the power. So, how do we remove the proportionality sign? It is R is equal to E, constant into concentration of nitrogen into concentration of hydrogen cube. So, that is known as law of mass action, right? Now, law of chemical equilibria. Equilibrium is the singular and equilibria is the plural form. Law of chemical equilibrium. This is what we apply to a maximum extent. Law of chemical equilibrium. For all equilibriums, this law is being applied. For all chemical reactions which are reversible attains the state of equilibrium. Right? So, here what do we state is that the ratio of the product of concentration of products, the ratio of product of concentration of products raised to its stoichiometric coefficient to the product of concentration of reactants. Each raised to its stoichiometric coefficient is a constant. What is that constant known as? Equilibrium constant. Wonderful. It is known as equilibrium constant. Okay. This ratio is a constant as the statement of law of equilibrium. Okay, and when the law of equilibrium is applied to a reaction, the constant, this ratio becomes equal to a constant, and that constant is titled as equilibrium constant. Right, equilibrium constant. For every reversible reaction at equilibrium, when it reaches equilibrium, the ratio of the product concentrations by the reactant concentration reaches a constant, and that is known as the equilibrium constant. So when we take a reaction, I took the same reaction, because this goes with the coefficients. The coefficients are not 1, and that's the reason why I have taken the same reaction. Now what is equilibrium constant? Yeah, Kc is equal to concentration of products raised to its coefficient by the product of concentration of the reactants raised to its coefficient. This is very important, that we will define the extent of the reaction based on the equilibrium constant. Okay, when an equilibrium is attained, we can't judge that the equilibrium is attained at 50%. Whereas the equilibrium attained depends on the stability of the reactants and products. If the reactant is more stable, the equilibrium is attained closer to the reactants. And if the product is more stable, the equilibrium is attained closer to the products. Right? So based on the stability of the reactants or the products, the equilibrium shifts here or there. Now, how does it shift, and what is the yield of the product is being judged by Le Chatelier's principle. It's based on Le Chatelier's principle. What is this principle? This is very important. I have not seen a question paper without this section. Every year at least one question comes from this section. So Le Chatelier's principle states that for a reaction which has attained equilibrium already, when the equilibrium is disturbed, the system will adjust itself so as to cancel the effect of the constraint. I repeat, when a reaction is already attained equilibrium, the equilibrium is disturbed with a change in temperature or pressure with any of the variables, the equilibrium is disturbed. The system will adjust itself so as to cancel the effect of the disturbance or the constraint, and equilibrium will be attained again, as Le Chatelier's principle. Right? It is not the statement of the principle which is coming for the examination. It is the application of Le Chatelier's principle which comes for the examination. Okay, the application. The first point is that what happens when the concentration is changed? What happens to the product when the concentration is changed? Say for example, we are taking a general reaction. Reactant is giving product. Now, if any one of the reactant concentration is increased, the already attained equilibrium is disturbed. And so, what do the reaction does is, the reaction will adjust in forming more products and the equilibrium will be retained. So, the effect of concentration states that if you increase any one of the reactant concentration, the yield of product will be more. The yield of product will be more. I mean, more products will be formed. Right? Now, what happens when we change the temperature? What happens when we change the temperature? The temperature effect is based on the endothermic or exothermic reaction. So, if I have written a reaction with the forward reaction endothermic, how do we know that the forward reaction is endothermic? Yeah, the delta H given value will be positive, and thus we know that the forward reaction is endothermic. So, if the delta OH given here is positive, then the forward reaction is endothermic. So in such cases, with more energy, the reaction takes place. So if you increase the temperature, more products will be formed in case if the forward reaction is endothermic. Okay, if the forward reaction is endothermic, backward reaction will be exothermic. Okay, so if you decrease the temperature, then backward reaction is favored, because forward reaction is endothermic. Endothermic reaction will be favored on increasing the temperature only. Okay, what happens if the forward reaction is exothermic? If the forward reaction is exothermic, you have to think a bit up in such a way that exothermic reactions are happening with the release of heat energy. So whatever is the heat amount of heat possessed in the system is not required, it is excess, and that's the reason why the extra or excess heat energy is released. In addition, if we heat, the product yield or product concentration decreases. Right? The product concentration decreases if the forward reaction is exothermic. Or you can predict in such a way that if the forward is exothermic, then backward is endothermic. If the forward is exothermic, then backward reaction is endothermic. So on increasing the temperature, backward reaction is favored and more reactants will be formed. Hope you have understood this part very clearly. Okay, so on increasing the temperature, only the endothermic reactions are favored. On increasing the temperature, exothermic will go down, the product yield will decrease. Right? And the next point is pressure. What happens to the pressure? I have written preferably this just because pressure, you have to think that we are compressing it. How do we increase the pressure? We have to compress. On compressing, what happens is, from more number of molecules, it goes to less number. So increasing the pressure, only the reactions from more number to less number will be favored. So here, to increase the yield of ammonia, we have to increase the pressure. Okay, in order to increase the yield of ammonia, we have to increase the pressure, because the number of reactant molecules here is 1 plus 3. 1 nitrogen and 3 hydrogen, so it is 1 plus 3, 4. Number of product molecules formed is again 2. So, if the number of reactant molecules are more than number of product molecules, then on increasing the pressure, the yield of product increases. Okay? On increasing the pressure, the yield of product increases. If it is reverse, if the number of reactants are less than the number of products, then on decreasing the pressure, more products will be formed. On decreasing the pressure, more products will be formed. So pressure will favor from more number to less number.